Hello everybody, I will be talking about hashing in this video. Okay, hashing is the method of organizing data within the hash table. Now let's suppose we are having this list of numbers. Let's suppose these are the keys. We will be storing these numbers within another table. Okay, there is another table of size 20 integer. These are also integer. Now let's suppose this is the original list 5, 17, 18, 10, 11 and so on. Okay, now this is our table. This is table, okay, of this are. Now what we will be doing is we'll be mapping these values 5, 17, 18 of original list to this table. Basic idea behind hashing is to map this value to this table. Okay, suppose this is 0, 1, 2 and so on. Now what we do is we use some hash function. Let's suppose we divide this 5 by 10 and get remainder 5. Okay, this is the 5 remainder. Now this is the hash value. Now we'll be storing 5 here. This value been mapped here. Okay, now we'll again divide 17 by 10 and take the remainder. The remainder will be 7. Now we'll store 17 here. This is 6, this is 7. Okay, now when 10 comes, 10 will be divided by 10 and remainder is 0. 10 will be stored here. Now what is the benefit of storing like this? Means we have used some function to store the data to this hash table. Okay, now we can directly know in which position of this hash table the original data is stored. That means we can do searching very efficiently. In one single comparison, we can find the position of the element within the hash table. 5 is in this 5th position, 17 in the 7th, I'm ignoring this 0, 10 in 0th position and so on. So using this hash function, we can arrange the original data within the hash table so that we can know in which position that element is stored. So this will increase our efficiency while sourcing the data. Okay, that is the basic idea behind hashing of the data. That will increase the performance of searching. There are different ways to do the hashing. Some of them are division method. This is an example of division method. Another is folding. There is chaining also. In this chaining, we will be using the linked list. In this video, I will be talking about folding method. Okay, in folding method, what happens is, let's suppose we are having the value something like this. Okay, we will add these individual digits. If we add these two, we will get 8. If we add these 2 digits, we will get 9. If we add all these 3 digits, we will get 4. Okay, 1 plus 2 plus. And are the hash values. Okay, hash value means these are the position of this element within the hash table. Suppose this is our hash table. Okay, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this 18 will be stored here, 17 will be stored here, and that's 121 will be stored here. Okay, in the folding method, what we do is we'll take the number and we'll add all digits of that number to get the hash value. But it is not compulsory that we have to add all the values of the number. Okay, we can take specific digits of that number, add those digits to get the hash value. Okay, so in this way we can arrange these individual numbers to the hash table. Now if we have to sort 17, what we do is we again hash this 17. We will get 8 and we'll directly go to this position and we'll find 17. If we have to find 121, then what we do is we'll add these individual digits, we'll get 4. Then we'll directly check in this table in the 4th position, we'll find 121. That means we can find the elements in one single comparison. That is the direct sourcing. So this is the basic idea behind hashing. But let's suppose we are having another value like this 22. This will also add up to 4. Okay, so this place has been already occupied by 221. Now we cannot store this 22 here. What we do is we'll search for another empty position within the list. Okay, after this we'll check whether this position is empty or not. If this is empty, we'll store here. There are different methods to resolve these things. If two or more keys hash to the same position, that situation is called hash collision. We can be using linear probing, we can be using quadratic probing to resolve the hash collision. So when we get this 22, we cannot store 22 here. We'll increase this hash value by 1. Okay, 4 plus 1, 5. And we'll check in this position. If this is empty, we'll store 22. This is linear probing. But what we can do is, instead of increasing this by 1, we can square this value. Okay, so if this position is not empty, okay, if there is already value, now this will be incremented and we'll make it 2 square. That means 14 plus 14, this is not 14, 4 plus 4, 8. So we will be taken here. This space is also not empty, so this will be incremented. This value will incremented, we'll make it 3. Now 3, 9 plus 14, 13. Okay, in the 13, if the space is available, then we will store this value. Okay, so this is quadratic probing. Now let's see how we can write program in the Java for this folding method. Okay, this is a very simple one. Okay, now let's define a class. Let's import one package first. Import java.util. Okay, class hash folding. Now let's declare an array, integer, arr, and table. Now this will contain the value provided by the user, and we'll map these values to this table. Okay, so now let's define constructor public hash folding int arr. Now this dot arr is equal to the table is equal to new. Now let's make a hash table bigger than our original array. Now let's suppose user has supplied 10 values, array of size 10. In that case we will be making array of size 30. Simple. Now let's use this method arrays dot fill table with some value. Okay, -1. Let's suppose that in this original list there will be no -1. This -1, -9, actually -9 will indicate the empty position within the array. Okay, now this is the constructor. Now let's write the folding method public. Okay, int fold int ele. Now what we have to do is we have to fold these individual values. Okay, we have to add all the digits of this value. Here I will be taking all the digits and I will sum those all the digits. Okay, simple. Now how we can do is they're very simple. Let's define variable integer yux. Okay, then integer I. Let's declare some values. Now let's give this let's declare only 2 variables. Now what we have to do is, let's suppose yux is equal to, now what we have to do while folding this is, we have to know how many digits are there. Okay, suppose in this case there are 3 digits. Okay, in this case there are 4 digits. Okay, now how we can know how many digits are there within a number? That is very simple. In Java there is a method math.log 10 and ele. This, if we provide 1 2 3 4 here, it will return 3 point something. Okay, so it will return 3 point something, and what we will do, we will convert that into the integer. That means we will get 3. If this 1 2 3 digit number is provided, this will return 2 point something, and if we convert it into integer, then it will become 2 only. So there are 3 digits, we got 2, so we'll be adding 1 here. That will make x is equal to 3, that the total number of digits of this number. So if there is 1 2 3 4, then this will return 3 point something something. So it will be converted to integer. It will become 3 plus 1 4. So we using this method statement, we can know how many digits are there within the number. Okay, now what we do here is, now we have to sum this individual values, individual digits. We have to get the sum of these individual digits. Okay, so now let's suppose I is equal to 0 here. Now let's assign this, while I is less than x, then whatever we supposed to, let's declare one more integer variable f. Okay, f is equal to, okay, we have to get the sum, so we have to declare sum also. Sum is equal to 0. F is equal to okay, what we have to do is element divide by math dot power I comma 10. Okay, not I comma 10, we have to raise the 10 to power I, 10 comma I. Okay, now what will what this will do is, this is suppose 1 2 3 4. Okay, this is 1 2 3 4. Math dot power 10, initially I is equal to 0, divided, suppose this is a 1 2 3 4, then this will be powered by, okay, this will not, okay, sorry, mistake, this is 1 2 3 4. Now this will become 1, 10 to power 0, this will become 4. Okay, now what we do is, we'll convert this into integer. Okay, then we will take modulus by 10. Okay, now what will happen is, if this number is taken modulus by 10, we will get 4 as the remainder. Now when i's value will be incremented, we have to increment the value of I. When I will become 1, this will become also 1. So when this is divided by 10, we will get 1 2 3, and when we take modulus of 1 2 3 by 10, we will get 3. Initially 4 3, so on we will be getting the individual digits of this number, and we will be adding these numbers. Okay, simple, very very simple. Now what we have to do is, sum is equal to f, then we have to increase this I by 1 also. Now that's it. Now this is very simple. We have to convert this into integer, because this is power method, log10 method returns real number. Okay, so we have to cast it into the integer. So in this way we can get the sum of these individual digits. Okay, so this loop will iterate to number of digits. Okay, how many number of digits are there, up to that number this loop will be iterating. Then what we have to do, integer, we have to return now this sum. Okay, this will be the position within the hash table. Now we have to write the hash method. Okay, now this, okay, public int, now let's array hash fold. Okay, simple, hash fold. Now what we have to do is, okay, we have the array, let's declare integer variable I. Okay, for I is equal to, okay, I also declare position also, I is equal to 0, I less than arr dot length. This is the original array provided. Okay, we have to map this array to the table. This is the array. So what we have to do here is, okay, for, now we have to get the position is equal to, now we will be using this hash fold method. Okay, so fold AARI. Okay, we will be iterating through each element of the array. Now what element of the array will be provided to this fold method, and this fold method will sum individual digits of that number and return the sum, and this sum will be stored within the position. Okay, now we have to do if table POS is not equal to -9. We have initialized all the members of this table to -1. 9 means it is empty. If it is not -9, then we will do table POS is equal to ARRI. Simple. Okay. If this is not empty, then we have to do linear probing or quadratic probing. Okay. Else, okay, QUA quadratic probing. Here we have to pass this position and this element also. Okay, this is closing. Now after this, okay, we have to close this for loop also. Now this array will be iterated one by one. Each element will be provided to this fold method. This will get the sum of individual digits of each element and assign that value to the post, and this will check within the table if this position is empty or not. If it's empty, we'll store the element here. Otherwise, we will be doing quadratic probing. If there is the hash collision, then we will be doing the quadratic probing. Okay. After the completion of the for loop, what we have to do is we have to return this table. Okay, simple. Now we have to write the method quadratic probing. Okay, public. Then we have to do void quadratic probing int POS int element. Okay, now we are having single element here. Now int I. Okay, then for I is equal to POS plus, okay, 1, okay, then I less than table dot length. Then we need one more variable, j is equal to 1. Okay, then we have to increment j. Then we have to update the value like this. I is equal to POS plus j multiplied by j. Okay, if position is 5, then initially this will become 6. 6 is less than table length, will be taken inside the body. Now we have to do if table I not equal to -9, we will assign this table I is equal to ELE. Simple. Then we will break this loop. Finished. Then we have to use this here. Close this, close this, close the class. Okay. Now what is happening here is, okay, let's suppose value of position is 5 and their collision occurred. Now this I will become 5 plus 1, 6. We will check within the table if the 6th position is empty, then we'll assign this value. Okay, and we'll break the loop. If the 6th position is not empty, then this will be executed. This j will become 2, then I will become 5 plus 2 into 2, that is, if this is 5, this will 6. If the 6th position is not empty, then this will be incremented, then 6, okay, position, okay, 6, okay, 5 plus 2 multiplied by 2. Okay, we'll get the 9. Okay, simple. We'll get the 9. If the 9, now this I will become 9. If this is empty, then we'll assign the element here. So in this way, we can do the quadratic probing. Okay, so in this way, we can use the folding, and if there occurs any kind of collision, it will be resolved with the help of quadratic probing. Now let's write the driver program. Okay, now class folding demo. Okay, public static void main string p. Now our class is hash folding. Hash folding h equal to, okay, new is the operator we have to use to create object. Hash folding. Now we have to, okay, no, I cannot do this. First I have to declare the array here because this is taking argument. Okay, so I have to first declare the array. Okay, first I have to declare array. Okay, now let's suppose we are having integer arr is equal to 22 and so on, like this. We are having the value. Now we can declare hash folding h is equal to new hash folding. Now we have to pass this array. Simple. Okay, now what we have to do is we have to declare another table, new int, let's suppose 30 size. Okay, fine. Okay, fine. Now table is equal to yes dot. Now what was the method? I just forgot. Okay, we have written hash fold. Okay, it is the hash fold. Now we have to call the method hash underscore fold, because this method will return the array. Okay, now you can see here. Now you can see here hash fold. Okay, this will return this table. Okay, in which the original value has been already mapped. Okay, this table will be returned, and we are assigning this table to our this table. Okay, now we have to simply display this table. Okay, for int I is equal to 0, I less than table dot length, then I plus plus. Now we have to check if table I is not equal to -9, then we'll display system dot out dot print ln plus table I. Okay, simple. This one is here, this one is here, this one is here, this one for the class. So in this way we can write the whole program for the folding method to hash the elements in the table using the concept of folding. We can write this whole program, and I think this will work perfectly. If there are some mistakes, there may be minor mistakes if there are mistakes. Okay, in this way we can store the data, original data that is provided in this array, and we can get these elements mapped to another table within this class, and we can get that table returned from that class. Okay, so here in this table we'll get all the mapped values. Okay, so simple. Okay, thank you very much for watching. Thank you very much.